Welcome to qnawire.
Hi, so over here we're going to have the following reaction, which is going to be contained in a 1 liter vessel. So we're given the initial quantities of H2, I2, and HI that are going to be present, and the value for Kc. With this, we want to know the equilibrium concentration of HI. So the first step is going to be to write down the concentrations for each of the components. In this case, since the vessel is of 1 liter, the concentrations are going to be directly equal to the amount of mole that we're going to have. 0.146, 0.146, and 1.98 molar. To know the direction of the reaction, we're going to look at the value for the coefficient of concentrations, which would be equal to the concentration of HI squared over the concentration of H2 times the concentration of I2. So the value of doing all of this is going to be equal to 183.9. As you can see, this value is going to be larger than Kc. Thus, the reaction is going to be shifted towards the left. With this, we can now write down the inverse reaction to generate our ice table, in which the equilibrium constant for this new equilibrium would be equal to 1 over the original one. So 1 over 39.1. So with this, we can now set up an ice table with the initial concentration that we have of each of the components. 1.98, 0.146, and 0.146. The amount of change is going to be minus 2x over here, plus x, and plus x on both sides. So at the equilibrium, we would get 1.98 minus 2x, 0.146 plus x, and 0.146 plus x. So now our expression is going to be for the new equilibrium constant, which remember that is equal to 1 over 39.10, it would be 0.146 plus x squared, which corresponds to the product of these two concentrations, divided by the concentration of HI squared due to the stoichiometric coefficient. We can rearrange this equation into a quadratic that would be equal to minus, I'm going to put all of the decimal points over here just to make it as accurate as possible. So after rearranging, the quadratic expression that we need to solve, 494558, is the following. Equal to 0, which you can solve using the quadratic formula or plugging this into your scientific calculator. Regardless of the method that you want to employ, the values for x1 and x2 are going to be minus 0.68, which is not going to have any physical meaning, and 0.1293. So with this, we can now calculate the concentration of HI at equilibrium. The value of x that we're going to employ is x2, of course, and this would be 1.98 minus 2 times x, which gives us 1.7214, or approximately 1.72 molar if we keep everything to 3 significant digits. And with that, it would be all. Thank you very much, and have a good one.